Good afternoon, everyone. I'm Zhao Yue from China UK Low Carbon College, Shanghai Jiao Tong University. Our team has conceived and designed a system to cope with one of the most strenuous tasks for the sustainable metropolis like Singapore, and we named this automatic sorting system with multiple sensors for recyclable domestic solid waste. And here is the main contents of my presentation. First, I will discuss the issues. And after we have checked the figures reported by the World Bank, we found that Singapore is the nation which has the highest level of the solid waste production annually. And among these, about 45% were recyclable. In order to support Singapore's Smart Nation 2025 plan, which highlighted the waste minimization and recycling, we decided to design a less harmful and less destructive domestic solid waste sorting system, and it is the sensor-based automatic sorting system for recyclable domestic solid waste. And we combined the near-infrared spectroscopy and computer vision to detect and classify these 6 kinds of the domestic solid waste, include plastics, metal, glass, carton, battery, and wire. And here is the state-of-the-art development and development. First, for the near-infrared spectroscopy, researchers combine it with the machine learning tools to automatically classify the different kinds of the plastics by their differences in the molecular structures. And with the assistance of these data processing tools and some self-generated neural network, for most practices, almost 100 classification precisions for most kind of plastics were achieved. And our lab also tried PCE, combination of PCE and PLSDA, and significantly improved the detection precision of confusing plastics like HDPE and LDPE. For computer vision, the researchers have tried a fairly wider ranges of the solid waste, including domestic waste, WEEE, and construction waste. And for the recent years' practices, most of them achieved more than 90% classification precision for each class set in the class with the assistance of the deep convolutional neural network. And also for the latest years, some researchers also achieved real-time detection and tried transfer learning. And then I will introduce our data construction. At first, I will introduce the process for our proposed domestic solid waste system. The first step, we will use the computer vision to to detect and classify the different kinds of the solid waste from the complex solid waste stream. And then we will use near-infrared spectroscopy to classify the solid waste within each class based on its compositions of the materials, and especially for the plastics, because it is sometimes very difficult to be classified due to its appearance. And for this, we can extract the resource with high value and high purity. And for the data set of the computer vision, we must take in the photos under the condition or similar to the condition of the task. And then we should try the best to obtain a similar number for each kind of objects for the classifications. This can help to mitigate the predisposition of the algorithms. And then we should randomly separate all the images into the training set and the data set, and all the images should be appropriately labeled. And for the near-infrared spectroscopy, we also use self-generated convolutional neural network to classify different kinds of plastics. And first, we collect the absorption spectrum. And for each object, we must detect no less than 5 points to reduce the error of the data. And then we use the SG filter and SNV to reduce the noise of the data and to correct the baseline. And then like the computer vision, we randomly separate the data into the training set and test sets. And I will also give an example of ourselves in the lab. And look at the images. These are sample images in the data set we obtained from our lab and from the website. And here are 3 different data sets we generated. The trash set, the parcel set, and the transfer set. These are for our original computer vision task and the transfer learning computer vision task. And this table briefly summarizes the information about these three tasks. And we can that after appropriate training, the mean average precision of all classes included were very high, and it's nearly about 100%. And look at the right, these are the data we obtained from the near-infrared detector. And we generate a three-layer convolutional neural network to detect this kind of the plastics, include PP, PS, and ABS, and we achieved 93% of mean average precision for all classes. Especially the PS and ABS are very challenging for the computer to classify. We also set an evaluation metrics for our system. First is the detection performance, and is widely applied for the computer vision and the machine learning methods, include the precision, recall, and location. Now the precision is crucial, however the recall should be gradually highlighted in the short future. Then for sorting efficiency, because for sorting efficiency, we should consider the detection speed and the disposal amount during the real operation. And finally, we also consider the social economic aspects. For example, for the input terminal, we should consider the expenditure in the equipment, in the labor, times for the training, and times for the transferring the equipment to our system. And the second, we should consider the output terminal. It mainly includes the resource recovery and include the reduction in the pollutions and to the harmful aspects to the residents. And to analyze our feasibility of our system, we should consider the technology, effectiveness, and social welfare. First is the technology. Because of the great development in technologies, it set solid foundations for our system. The sensor and computing hardware can help us to generate the information and data quickly and computing them to generate a result very fast. And algorithms can help us to extract the features from these images and from the spectrums accurately. And the previous successful practices will give our many experiences in the scenario selections, in the dataset constructions. Also the effectiveness. For most practices and also the practice of ourselves achieved real-time detection and classification with very satisfying results. Also, our system has a low threshold for operators. For the operators not expertise in the computer science can also cope with this, apply to our method to use in the real condition. And finally, our system can virtually reduce the pollution, to reduce the health threat to the residents by promoting the resource recovery. And I will introduce some potential future directions in this field. First is the dataset. The composition and structure of the dataset is still crucial to the machine learning tools, and it's very crucial to our proposed system. And we should consider the task-based, and we should also consider the multiple sensors. And second, the mechanical issue should be highlighted in the future, for the robotic arms are executing body in the system. And finally, the scenario. The specific scenario of solid waste treatment impose decisive impacts on the dataset and the mechanical issue. And for the waste stream, there have very complex and complex compositions. Hence, this should be further discussed in the future. Okay, I will discuss the dataset construction. In the future, the data construction should consider the task-based and multi-sensors. For the task-based, we must also consider the waste sorting task, the task-based. For the waste sorting task, the data set should be constructed based on the specific task. For example, the waste stream with very complex compositions and the waste stream with confusing background. The second is the machine learning task. Because sometimes the data set or the good quality data set is very difficult to be obtained in the real operation. Therefore, the different machine learning tasks may be selected. And we should generate different kinds and a different structure of the data set. And also, our system combines different kinds of sensors. The fusion of the sensors data is important. The first is the results fusion. We forming the data set separately from different sensors and then generate the results also separately. However, we will fuse the results obtained from different sensors into an appropriate form and to instruct a robotic arm. And the second is the data fusion. The data fusion refers to the collect data separately from the different sensors and fuse the data into a same pattern to simultaneously generate a result and to instruct the robotic arm. And I also gave an example in this field. Okay, here is the latest papers of our lab. Thank you for your patient listening and attention.